Okay, how you doing? We're back to the number systems or sliding scale. Here's a copy of them I designed. You could make copies on ribbons, mark them with colors. We have colored pencils over here. And I'm not going to show you, I'm just going to throw you some methodical way. If you kept this board up at the office, everybody would use the same kind of process to do their electrical circuits. In the military, C1 part reference numbers would be the same, and it's more effective to do it all the same way. So I made it into charts instead of a reference book, just for myself. All right, so you're doing your as I showed you, the part number. Your hexagonal would be a grid. Also, with the scale, you could keep track in a numerical fashion from left to right, moving from numbers and then keeping them in your logbook. Over here we have printed circuit boards. Printed circuit boards are eight layers thick. They can go up to 8 layers thick. This is a ladder. Then there's a manhole. The manholes go down each layer and they have traces. They run on a binary digit system, which with the and or logic system flow charts, this shows and they're combined, or switches, not doesn't switch, not and, both and not or. Now let's move on to cross command keys, DOS key. Real quick, I'll show you what it's. I'm doing this video, I'm taping this video myself. DOS keys, writing a simple DOS program. We write as if the MS-DOS commands are thought and typed individually. The command specifies and checks the MS-DOS command and carried out in 3 parameters. If not commission in command, not reverse in the meaning of command, a command can carry it out only if the condition is not true. And conditions check has 2 commonly used forms. Exist in string number 1. The file name and check whether the name of the file exists, include a path over the existing necessary file name exists if the condition is true. String 1 equals string 2 compares the 2 character strings. Specific if they are identical true. Note that they are 2 equal signs. So I did a quick page right here. This is the diagnostic program that I wrote for locomotive air brakes. It shows the independent maximum switching of number 2 control stand number 2 system, independent handle, the delay counter, the independent smack switch open batch means that's an execute file, and it's written with backwards C prompts. That means when you put it in Notepad, it will make its own. So your independent handle on your train would be equal to or below with 328 hertz, equal to the delay counter in 2 seconds. And then, if the independent max is open, and the message code would then display independent max stuck, open, space, enter, and that's how you close the thing. And you would get the area, it would show the aerodynamic code, message switch, batch file, independent stuck open, auto error execute copy. It would then run an auto area independent max switch cutout that is open fault code 1 into the fault bin. It would take time, space, dated, and stamped, and the troubleshooting diagnostic. So what we did is we have our circuit boards. They develop. We have this known as binary decimal positioning, and you can see these lines. Think about it as a war flanking game. You mirror this to the side, you flip this up, you flip that up. When you mirror, the binary digits come in 0 to 1. And here's the difference. I should take this apart and restaple. I'm going to take it apart. Decimal 1, double zeros, 10, 11, and it goes down to 10. If you see the pattern, you can see a nice street slope curve. Then we have binary pulse codes. These are put in. They come in the effective true value. 1 would meet on, enable, 0 would be off. So these are the different ways. If you had and, they would both be on. And these use cumulative adapt laws. Ohm's laws, you know. So I showed you a quick page on MS-DOS. I read to you a little bit about DOS and string lines and how they work. Think about telling it an if or not and with string equals to get your program ready. Then when you put it on the printed circuit board, you can watch OrCAD, and you would be designing logical amplifier circuits. And these are the Boolean laws. As you can see, you got the law identity immune associated and double negatives. They're basically what you learn in school. Diagnostic digital display. Back to the logs and creating a DOS. You would show low oil pressure motor 1. It would tell and it would send off the alarm. You would use your and or logic gates after your flow chart load resistor, and it will check. There's different ones. So you make a flow chart. These show cold engine motors. Here would be a circuit drawing. This one is of shut down low water oil flow. You can see has a shift key, a diode, a sensor, a motor. So I don't really have very many electrical schematics, thinking that you already know how to do electrical schematics. So we got through the laws, the DOS keys. We could printed circuit boards. All right, back to the part display. All right, we take a grid notebook. We take this grid, we labeled our parts with a mil spec, and you could use it, you could keep count with the individual tabs. Once you start getting more and more parts, and you assign the reference description detail number with the part number, the part description, in your log with the resistor logic indicator, capacitator, or whether it's a fuse or not. And that's how we keep signals. As you can see, there's let's push, this is back in the set position. I'm not going to be able to do this one one-handed, but all right, you see the pi and the different degrees, minusing sins and cosines and tangents, which will mate or create these waves right here. So with these waves, we have radio frequencies broadcasting the isotopes into the atmosphere, and they range in nautical miles and 164 yards or feet per second. We have different broadbands, upper and lower bands, which get to the point where the part specs they have their own reference sheet. Once again, with a ruler, you could note these four, just scale lines up and over. Remember that on a PC board, they do not use right angles. They prefer 135 degrees. But keeping the inspection log, move on to the next scale over from this one, and keep your capacitors in a numerical order with the spec identification sheet. Right, the spec sheet, identifier, specification sheet, and color designator. These are designated in colors. In the bands, we will have black, brown, orange, yellow, green, blue, gray, white, and old. Yellow, I didn't color code this. There's resistor colors, same thing, but different colors, shows different multipliers and tolerances. And then this one shows different capacitors. So they're color coded, and we'll get to that in video 3. Once again, we showed you that this shows pi's in 360 degrees, and in pi inverses and angles to do cosine, sin, and tangent. We'll print out your bars. We did frequencies. Your modulation index shows the specific sidebands. That will be on the next one. Decibel gains, which all comes into trigonomic functions. With this, you can learn how to use this. This is $30 ruler. Teach you easy way to get your math sheet done without even looking at a trigonometry book. But just in case you want to log the to a certain decimal place, I can see it. Logarithms come in the chart. Common logarithms numbers 0, 1 through 10, and then 1 through 9, and then 10 down. And then hexadecimal numbers. Pi does the same thing. It runs a scroll and then it goes back and it logs it. Okay, so we did decimal notation. Decimal to binary. They come in 4 bits. They're used in 0-1 sequence binary. You have television channels, and these show the band limits to your decibels and megahertz, and how many band limits there are. It would be an upper and lower for channel 2 of 50 and 60, meeting a carrier strength in between. And Morse code also makes a script or a logarithm very neat in binary decimal positions, which shows marked dotting, spacing, and then dashing. So, and then if you had to see it in waveform, binary waveform, we have these different wavelengths. We did I'm not very big on, I haven't done any printed circuit boards, but I led the tutorial to OrCAD. It's a program I can't afford. Milled the specifications. We went over capacitors, colors, rings, and bands. It shows the color coding, semiconductor color coding rules, like keeping the same template for each family of cathodes. And in the office is why this should be on a reference board. Shows grounds, black, brown, beaters, power supplies, red, and you can read it. Okay, so that's tape 1.